Welcome to Mastery Algebra 1. I am Mr. Fuller, and this lesson is from Chapter 1, Section 1 on variables and expressions. Math is very much like a foreign language. It has its own vocabulary, and also we use some terms that come from everyday English but have different meanings. So in this lesson, we're going to learn some vocabulary words and practice using them. The first word we're going to learn here is called quantity. A mathematical quantity is anything that can be measured or counted, such as the number of shoes you have in your closet right now. Some quantities don't change. We say they remain constant, like the number of windows you have in your room at home or in your house as a whole. Others change or vary and are called variable quantities. That might be the number of people in your house. That changes at different times during the day. Algebra uses symbols to represent quantities that are unknown or that vary. You can represent mathematical phrases and real-world relationships using symbols and operations. We're going to be practicing a lot of that in this section. A variable is a symbol, usually a letter, that represents either an unknown value or a value that can vary. An algebraic expression is a mathematical phrase that includes one or more variables. So if you see a letter in there, it's an algebraic expression. What if it doesn't have a letter in there, like 2 plus 3? That's what we call a numerical expression. That's a mathematical phrase involving numbers and operation symbols, but no variables. Let's practice some examples. How can we turn words into math symbols? So here's a question. What's an algebraic expression for the given word phrase? In 1a, we need to represent 32 more than a number n. Well, if you're going to get more than something, you're going to have to add on to it. So if I need 32 more, I'm going to have to add 32. So to get 32 more than a number n, I need to take n and add 32. Now, some of you might have been thinking in your head before you saw that it should be 32 plus n. Well, let's try that with an example. Let's put some numbers in there. Let's say that n represents the number 5. So the first expression would be 5 plus 32. That's the same as the number 37. If we let n be 5 in the second expression, then we get 32 plus 5, which is also 37. So those two expressions are equivalent, and it really doesn't matter if you write n plus 32 or 32 plus n. But let's be careful. That's not always true. In example B here, we need to write 58 less than a number n. Well, it makes sense. If you want to get less than something, you're going to have to subtract. So if we want to get 58 less than something, we're going to have to subtract 58. So to get 58 less than a number n, we're going to have to take n and subtract 58. Now, some of you might be thinking, well, how about if we wrote it as 58 minus n? That is not going to work. Let's see if we can figure out why. If we were to let n be the number 60, then the first expression is 60 minus 58, which is 2. The second expression is 58 minus 60, which is negative 2. Those are not the same, and therefore the second way of writing the expression is not correct. You can't switch them around when you're dealing with less than in the same way that you can when you're doing more than. How about example C? 58 less a number n. Yeah, read that carefully. It doesn't say 58 less than a number n. It says 58 less a number n. So when you see less without than, then it just means subtract. So in this case, we will get 58 minus n. In example 2, we need to write 8 times a number n. Well, times means multiply, so we need to write 8 multiply by n. The easiest way to write that is to simply put the 8 next to the n and leave out your little x for multiplying. Sometimes people use a dot, but you don't need either one. You can just write 8n, and that means 8 times n. In example 2b, the quotient is a word that means division. So we need to divide two numbers. Well, which numbers do we divide? Well, we keep reading. And when it says the quotient of, whatever comes after of is going to be the two things you have to divide, and they're going to be separated by the word and. So we need the quotient of a number n, that's the first part, and 5, that's the second part. So we need the number n divided by 5. We usually write that in a fraction form to show the quotient, although it would be correct if you wrote n divide symbol 5. All right, so now you have a chance to see if you've got it. So take a minute and write the answers to these. Pause the video before you do it, and when you're done, then come back and check your answers. All right, take a look at your answers and see how you did. Now it's time for some more examples. A little bit more complicated with more steps in them. What's an algebraic expression for the word phrase 3 more than twice a number x? So there's two things going on here. There's more than, which tells us we're going to have to be adding 3, and then we have this other part, twice a number x. Well, to get twice as much as something, you have to multiply it by 2. So this is telling us two different operations. We have to add 3 and we have to multiply by 2. So we know we're going to be adding 3 to something. That's going to be the plus 3 at the end. And what do we add the 3 onto? We add it onto twice a number x, or 2x. So a good answer, or the best answer to that one, would be 2x plus 3, or, well, I guess we are using the letter x here. Technically, we could substitute any letter and it would have the same meaning. For example, 3b, 9 less than the quotient of 6 and a number, again indicates two operations. Less than, 9 less than means we're going to be subtracting 9. And then the quotient tells us we're going to be dividing the 6 and a number. Now, we don't know what letter to put in the place of that number, so let's use y this time. So the quotient of 6 and the number y would be 6 divided by y. To get 9 less than that, we would have to subtract 9. So 6 over y minus 9 is the best answer to letter B. In example 3c, we want the product of, and that's a phrase that means multiply. So we're going to be multiplying 4, and then there's an expression here. We're going to multiply 4 and this. Well, this second part has an operation inside itself. So this is the sum of a number, let's call it n this time, and 7. So the sum of a number is n and 7. We want the product of that and 4. We want to take 4 and multiply it by n plus 7. So 4 parentheses n plus 7 is the best way to write that. All right, now pause the video for as long as it takes to finish example, or got it, 3a, b, and c, and then come back and check your answers and see how you've done. All right, how did you do on got it, number 3? If you're confused, you can go back and rewind the video and watch it again, or just make a mental note and learn from whatever mistake you've made. Or if you think you might be right and you have something different, ask me in class tomorrow. All right, more examples. Number 4, what word phrase can you use to represent the algebraic expression 3x? Well, when you put a number next to a letter like that, it means 3 times x. So how could we represent that in words? Well, we could write 3 times the number x. Or we could use that other word that means multiply, product. So we could call this the product of 3 and a number. We usually prefer the more sophisticated wording rather than just using the word times. So take a minute, pause the video, and try these for got it 4, A, B, C, and D. There are different ways that you can phrase these and still be correct. You don't have to say more than. You could say the sum of. Same thing in part B. There are different ways you can phrase these, but these are correct answers that should give you an idea what sort of things you should be writing for these types of problems. If you have something way different that you think might be correct, show me your packet when you come to class. Show your teacher your packet and let them check it for you. All right, more examples, number 5. So now we're going to get into some applications of these things. How do we use these types of words and variables and expressions in everyday life problems? So the table below shows how the height above the floor of a house of cards depends on the number of levels in the house of cards. So you can see the picture at the right if you're not sure what a house of cards is. So what is a rule for the height? Give the rule in words and as an algebraic expression. So what we have is we have a table that shows us the rule for the height. It shows us how if we know the number of levels, we can figure out what is the height of the house of cards. So if you look carefully at what's happening in the height column, you can see that we're taking the number of levels, which is 2, multiplying it by 3.5, and then adding 24. And when the number of levels is 3, we take the number of levels, 3, and we multiply it by 3.5 and add 24. And then when the number of levels is 4, we take 4 and multiply it by 3.5 and add 24. So if the number of levels is n, it feels like we should take n, multiply it by 3.5 to get 3.5n, and then add 24. So that is a rule written as an algebraic expression, and technically we were saying, or I was saying the words as we wrote that rule. Okay, take the number of levels, that's your n. We're going to take the number of levels, multiply by 3.5, and add 24. Now you could say this in many other ways. You could say the sum of 3.5 times the number of levels and 24. Or you could say the product of 3.5 and n plus 24. There are many different ways that you could phrase this, but there is an example that gives you an idea. Now, why don't you take a moment and try B and C. Pause the video, write out your answers to those, and then come back and check your answers. All right, how did you do on B and C? Again, remember, there are different ways that you can phrase the words to get the same meaning. All right, you're going to be finishing up this packet by completing the page called 1-1 Practice, or Practice 1-1, and you can see it here in the video. That's the page in your packet you need to complete on your own now, and then bring your completed packet back to class so it can be checked, and if it looks like you are ready, then you will be able to take Mastery Quiz 1-1.